Sathyabama Institute of Science and Technology.
Hello everyone, this is Poornapushpakala from the Department of Electronics and Communication Engineering from Sathyabama Institute of Science and Technology. So today we are going to discuss block diagram reduction from control system topic. So what is block diagram? So block diagram is a schematic of a system in which the principal parts or the functions are represented in blocks connected by lines that show the relationship of the blocks. Okay. So, the block diagram can be used to represent the composition and interconnections of a system. So, it can illustrate, the block diagram can illustrate cause and effect relationship in a control system. Okay. It can also be used to identify the manipulated and controlled variables and input outputs of a system. So, this block diagram represents a system where you have input, output, and it is connected with an amplifier, a servo motor, you have a feedback and a error detector. So, this implies a block diagram. So, by seeing the block diagram, one can understand what is the system and how the signal flow is in the system, what are all the components connected in the system, what is the relationship between the input and output. So, why we need to do the block diagram reduction? So, a complex system is represented by interconnections of the blocks for individual elements. Okay. So, the evaluation of the complex system requires simplification of the block diagram or by rearranging the block diagram or reducing the block diagram. So, when you rearrange or reduce the block diagram, we can able to get the characteristics of the system by reducing the block diagram. So, if you have a complex system, we can reduce and find the transfer function of a complex system. So, to derive the transfer function of the complex system, we can go for block diagram reduction. So, before seeing the block diagram reduction, we have certain set of rules for reducing the block diagram or rearranging the block diagram. So, first we are going to see the rules of the block diagram reduction. So, the first rule is combining blocks in cascade. So, that is when the blocks are connected in series, you can combine those two blocks to reduce the block. So, we can simply multiply G1 and G2 to combine these two blocks in cascade. So, one thing we have to remember that the blocks in cascade can be combined if there is no summing point or takeoff point in between, then we can combine the blocks. Next is combining the blocks in parallel. So, if you have blocks in parallel like this, so you can see G1 is added here, this is a summing point, okay. G2 is also added to the summing point. So, from input side it goes to the output side, G2 is going to the output side, this is called as a feed forward path, okay, or these can be represented as blocks in parallel. If that is the case, we can simply add whatever is the symbol at the summing point, that has to be taken care. So, here both are plus, so G1 plus G2. If it is minus, then G1 minus G2. So, combining blocks in parallel, we can simply add the blocks. So, next is moving a summing point after the block. So, you have a summing point, you are going to move this summing point after this block. So, what is the signal that is added to this summing point is x1 and x2, okay. So, if we are going to move the summing point after this block, so what we have to do? So, what is the output of this summing point? x1 plus x2. So, it is multiplied with the g. So, the final output is g into x1 plus x2, okay. When we are going to move the summing point after this block, the signal, the output signal should not be changed, right. So, here x1 is coming, the block is g, now the summing point is moved here. So that means the output is x1g. Okay. So here x2 should be added, but we are going to move this summing point which is having x2. So the output is g into x1 plus x2. So this output should not be changing. So the output we want is g into x1 plus x2. So when you are giving only x2, it will be x1g plus x2, but we want x1 plus x2 into g. So we are going to multiply g in the path. Okay. So the output is g into x1 plus x2. So moving a summing point after the block to the summing point, the g will be multiplied. Okay. So next is moving a summing point before the block. So you have a summing point here, we are going to move this summing point before the block. So what is the output of this after this block? x1g is the output of this block, right? So here x2 is added. So the output of this block is x1g plus x2. Okay. So when we are moving this before the block, this output should not be changed. Okay. The signal should not be altered when we are rearranging the blocks. Okay. So here now we are moving this summing point before the block. That means to x2 g will be multiplied, but the output is x1g plus x2 only. That means here we need to divide this by g. So x2 by g. So this summing point x1 plus x2 by g, when it is multiplied with g, finally you will be getting x1g plus x2, the same output. Okay. So when we are doing the block diagram reduction or rearranging the block diagram, we have to see to that the signal is not altered. So next is moving a takeoff point, or we can also call it as a branching point. So moving a branching point after the block. Okay. So you have a branching point here. We are going to move this branching point after the block. Okay. So you have this block. So here x1 output from here, if you are taking a branching point, okay, whatever is the signal, that signal is going to come. So from x1 we are taking the branching point, that means that signal is also x1. Okay. So if here it is multiplied, the output is x1 into g, right? Now if we want to move this takeoff point after the block, what is going to happen? It is going to be multiplied with g. So the output is x1g. When you are taking a branching point from here, that output is going to be x1g, but what we want only x1. So we are dividing by g, okay, to get the x1 signal. Okay. So moving a takeoff point after a block, it is going to be divided by g. Next is moving a takeoff point before the block. So you have a takeoff point here. So x1g, from here if you are taking a branching point, that signal is going to be x1g, right? When we are going to move this before the block, then for that takeoff point it is going to be x1 only, but the signal from here is x1g. So you have to multiply that with g. Okay. So from here if you are taking, that output is going to be x1g. So you need to multiply g. Next is eliminating feedback loop. So you have a block, you have a feedback path. So g, h is the feedback path. Okay. Here you have a summing point. So x1 is added to the summing point and the feedback is also added to the summing point, right? So when we are taking the output, so here this is the error detector. So what you are going to get? The difference. Okay. The difference you are going to get. So x1, what is the signal coming here? x2. So output of this is going to be x2 into h, right? Here we are going to make the difference. So x1 minus x2 into h, okay, that is going to be multiplied with g. So your x2 is going to be x1 minus x2 into h into g, that is your x2. Okay. So when we are bringing this x2 gh over here, this will become x2 into 1 plus gh, which is equal to x1 into g, right. So, x2 divided by x1 is going to be g divided by 1 plus gh. So, when you are going to eliminate this feedback loop, okay, so it can be replaced by a single block where x2 by x1 is equal to g by 1 plus gh. If the feedback is minus, okay, then we are going to get plus here. If the feedback is plus, then we are going to get a minus here. So, if the feedback is plus or minus, this output is going to be minus or plus, okay. So, g divided by 1 minus or plus gh. So, that is what is eliminating the feedback loop. So, the next is interchanging the summing point. So, if you have two summing point adjacent to each other, then we can interchange the summing point provided there is no takeoff point in between or there is no blocks in between. If you have two adjacent summing points, okay, then we can interchange the summing points. Then splitting the summing point. So, if you have a summing point where three signals are coming, we can split the summing point into two, where two signals at each summing point we can split, okay. We can combine the summing points. So, this is vice versa. So, we can do split the summing point as well as combine the summing point. So, if you have two summing points like this without any block or takeoff point in between, we can combine those summing points. So, combined summing point we can split and split summing point we can combine. So, both way we can do. So, now we are going to see a problem where we are going to find the transfer function of a given block diagram. So, this is a given block diagram. So, we are going to derive the transfer function of the system, okay. So, C of S is the output, R of S is the input. So, by applying these rules whatever we have discussed now, we are going to rearrange and reduce the blocks and bring it to a final transfer function, okay. We are going to derive the transfer function. So, first step, like each one can solve the block diagram reduction in their own way, but see to that the rules, you are following the rules and the signals are not changing, okay. So, this is the block. So, first what I am going to do, so from here feedback is coming, this is a unity feedback, okay. So, if you have a single line, that is a unity feedback, that means the feedback element is 1, okay. See, if you see the signal path, so from here the signal goes here, okay, and it goes over here also. Here we have two feedback element H1 and H2. So, the first step what I am going to do is, I am going to split this feedback into two. So, rearranging the branching point. So, from here I had a branching point. So, I am just rearranging the branching point. So, from here I am taking this branching point separately, and from here another branching point, it goes to the summing point. Now, the feedback loop is separated. Now, if you see H1 and H2 are connected in series, okay. So, we can combine these two blocks H1 and H2, correct. So, I am just combining these blocks H1 and H2. Now, if you see here G4 and H1 and H2, we can eliminate this feedback loop, correct. So, here the sign is minus. So, G4 divided by 1 plus G4 into H1 H2. So, we can eliminate this feedback loop, okay. So, if we eliminate this feedback loop, we have G4 by 1 plus G4 H1 H2. So, when we have eliminated this feedback loop, the summing point along with the feedback path, everything will be eliminated, okay. So, if we have eliminated that, now if you see G3 and this block is in cascade. So, we can combine these two blocks, right. So, the next step is combining these two blocks. So, simply multiply G3 G4 by 1 plus G4 H1 H2, right. If you see here, what is the next step we can do? We have to think. So, we can't combine these two because we have a takeoff point here. So, what we can do? We can move this takeoff point after the block. So, the rule is you can move the takeoff point before or after a block. So, I am going to move this takeoff point after the block. So, if I am going to move the takeoff point after the block, what I have to do? I have to divide by G, whatever is here. Am I right? So, H4 is the original feedback path. Okay. So, now since I have moved this takeoff point over here to after this block, I have to divide by this block, right. So, for dividing I have just inverted it. So, 1 plus G4 H1 H2 by G3 G4. Okay. Now, if you see, these two are in cascade and these two are in cascade. So, I can combine these two and combine these two. So, the next step we have combined G2 here. So, G2 G3 G4 by 1 plus G4 H1 H2. Okay. Next we are going to combine this. So, when you are combining this, 1 plus G4 H1 H2 into H4 divided by G3 G4. Okay. So, if you see now, this feedback path we can eliminate. So, this is your G and this is your H. So, G divided by 1, here you have plus, so 1 minus G into H, right. So, if we do that, see here, this is your G. So, we are going to do G divided by 1 minus G into H was your H3, right. So, if you simplify this, you are going to get G2 G3 G4 divided by 1 plus G1 H1 H2 minus G2 G3 G4 H3. Okay, this is what we are going to get. So, I am going to replace this over here. So, the entire block, right, that eliminating that feedback loop. Now, if you see here, this and this we can combine G1, G2, G3, G4 divided by this, right. So, now I have combined G1, G2, G3 divided by 1 plus G4 H1 H2 minus G2, G3, G4 H3. Okay. Now, if you see here, this two summing points, so we cannot combine, we cannot eliminate this feedback loop because this summing point is over here. Okay, this summing point, whatever is coming, this is over here. So, what I can do? I can interchange this summing points. So, if I rearrange the summing points, if I interchange the summing points, my feedback loop will be free so that I can eliminate the feedback loop, right. So, I am going to interchange these two summing points, right. So, if I interchange these two summing points, now this feedback loop is free for me for elimination. Now, if you see, the entire thing is your G, this is your H. Okay. So, the summing feedback is negative feedback minus. So, G divided by 1 plus G into H. So, this is your G, this is your H. Okay. So, if we reduce this, what we got? This is what we got, G1, G2, G3, G4 divided by 1 plus G4 H1 H2 minus G2 G3 G4 H3 plus G1 G2 H4 plus G1 G2 G4 H1 H2 H4. So, this is what is we got after eliminating the feedback path. Okay. Now, if we see, there is a G block and a feedback with the unity feedback, that means G divided by 1 plus, because here it is minus sign. So, G, this entire thing is going to be your G, H is going to be 1. So, G divided by 1 plus G into H, right. If you do that, you are finally going to get your transfer function, right. So after reducing this, eliminating the feedback loop, this is what the transfer function what we have obtained. So C of S by R of S is equal to G1, G2, G3, G4 divided by 1 plus G4, H1, H2 minus G2, G3, G4, H3 plus G1, G2, H4 plus G1, G2, G4, H1, H2, H4 plus G1, G2, G3, G4. So this is the final transfer function of the block diagram what we have seen. So this is how you have to reduce the block diagram. So you have to use the block diagram reduction rules carefully and do. Each one can solve in their own way, but the answer is going to be the same if you are doing it correct. Okay. Thank you all.